Okay, this is part B. This is 2003. Is it 2003? 2003, question 23. We did half of it last day. We're just looking at the second half just now. The mass of the water in the tank is 2.7 times 10 to the 3 kilograms. The tank is a mass of 300 kilograms on a flat rectangular base. The dimension of the tanker is shown. Atmospheric pressure is that. Calculate total pressure exerted by the base on the tank on the surface on which it rests. We already agreed last day that we're going to add on atmospheric pressure to whatever extra pressure we had. To get pressure, we think about what information is the question given us. It's given us the mass, which is one thing. It's given us the dimensions, this is another. From the dimensions we can get surface area. From the mass we can get the weight, and the weight is the force at which it's pushing down. So we know the force at which it's pushing down, we know the surface area. Pressure is force over area, so we can get the pressure by which the tank is pushing down on the worktop, on the surface, and then we can add on atmospheric pressure to that. Okay? So, Carson, what did you get?
For the answer?
I
didn't even I'm still trying to work out what I did wrong.
Did wrong? Now, a few of you worked at the answer. Andrew? 110,800. 110,800 pascals should be your answer. If you're not getting to that stage, you need to show me when you're working and let me see where you're going wrong. Okay, before we do that, I just want to show you the homework. Make sure we're all aware of the homework we've got. I put up the homework last night. Homework out, mechanics, buoyancy. So last night, okay, that was the solutions for the two homework questions, homeworks 2 and 3. And then the homework I'd like to do is question 23 from 2005. Guys, this way. Question 23 from 2005, question 23, and 2000, question 23 as well. Okay, now what I'm going to start doing is I'm not going to just be putting up the single question that we're doing. I'm just going to put up the whole past paper and you pick the question out of it you need to do. It saves me a lot of work. So I'm giving you this higher 2005, this higher 2000. The whole paper's there, you just go in and take out question 23. Somebody already done this? Somebody must have already done this, because there's 2 clicks on it and I've not clicked on it. Nobody's done it? Oh well. It's not lying. Right, the other thing which I've done, which will help you at some point, is I've added more past papers and more solutions. So now I have all the way back to 2000. Past papers and solutions. Okay? Now, stop that. Right, the solutions for your past papers are online, but I just don't have to tell you that it's not about being able to do them, it's being able to do them and understand them, okay? So, if you're really stuck with the homework, you come and get help off me first and foremost. Don't be looking at the answers. Okay, the answers are there to help you if you want, but I'd rather you understood it. Try looking at the answers if you want. Okay, let's just say you can look at the answers if you want. The point is, if you understand it, be honest with yourself. You're the one that's going to have to do the nav, not me. So be able to make sure you can understand what the answers are telling you. Okay, so today we're going to look at a few other past paper questions. We're going to look at 2000 and what one did I ask you to do?
2005 question.
I just don't want to ask you the ones that I gave you for homework. I'm going to ask you different ones in class.
When is that now? For the mechanics?
We're going to finish to be another after October holidays. Be 2 weeks something after October holidays, 1 week after October holidays. Right, 2005 question 2, so we're going to do that one, and 2000 question 23. So we're going to do 2004 question 23. So 2004 question 23. I'm going to talk you through it, and then I'm going to give you your 12 minutes to do it. Right, here we have a crane barge is used to place part of an oil well called a manifold on the seabed. The manifold is a cylinder of uniform cross-sectional area, so there it gives you the surface area should you need it, and a mass of 5 times 10 to 4 kilograms. There's your mass. The mass of the cable may be ignored. It's important to remember that. Calculate the tension in the cable when the manifold is held stationary above the surface of the water. Held stationary means it's not moving, which means the forces are balanced. Whatever force is acting on the manifold must be balanced. So weight is acting down, so tension must be acting up. So when you get your weight, you have your tension.
Yes.
The manifold is lowered into the water. and held stationary just below the surface as shown. Draw a sketch showing all the forces acting vertically on the manifold. Name each of these forces. The tension of the cable is now that. So know that the difference in pressure between the top and the bottom surfaces of the manifold is that. And the manifold now lowered to a greater depth. What effect does this have on the difference in pressure between the top and the bottom surfaces of the manifold? Let me justify your answer. So it's rho GH is to work out your pressure at different depths. Pressure difference top and bottom will give you your overall force required. So I'm going to get this zoomed in. I'm going to put 12 minutes up, and I'm going to give you, in fact, I'll give you 15 minutes just to do the whole lot. There you go, it's 7 marks. I'm going to give you 15 minutes to get the whole lot up, and then we'll see how we go on after the 15 minutes. So where's my tools? Clock. There's the clock. Try and put it somewhere in the side. Okay, so I'll give you 50 minutes to